So today we're going to start the second part of Unit 8. The first part was a lot of skills. In the second part, we're going to explain where we use those. So to start this quadratic part, we are going to be graphing today. We have actually already talked about a lot of this, about what the shape of this quadratic should look like back in Unit 3 when we were doing function families. So you might feel like this is a little bit familiar, at least part of it. We're also going to be picking up some new vocabulary as we go through. Now, before we move forward, I just want you to notice the quadratic dude here, face emoji on the screen, because parts of that are going to come up as we go through. And there's also two little graphs here that will be on the notes page that kind of give you an idea of what we're talking about, at least for part of today. So let's start with our vocabulary. A quadratic function is a function that can be written in the standard form y equals ax squared plus bx plus c, where a cannot equal 0, because if a equaled 0, this term would become 0 and you'd have a linear function because the x squared term would be taken out. When you look at the ax squared plus bx plus c, that looks familiar from the first part of the unit when we were talking about factoring. So I promise you, in a couple of days, we're going to finally figure out why we had to do factoring. It's part of a quadratic function. So our input is going to be x, our output is going to be y, and these a, the b, and the c are going to be numbers that are going to affect where that graph, where that curve goes on the coordinate plane. So here are some examples of quadratic functions. So you'll notice this one is y equals ax squared. There's only an a, b, and c are both 0. When we go to the second one, it's y equals a is the invisible one, x squared plus 2. We're missing the bx term. And then finally, y equals negative x squared minus x minus 3. And we have an a of negative 1, a b of negative 1, and a c of negative 3. So this general function, the variables are the x and y. The a, b, and c are just placeholders that will be numbers. We're going to talk just about the first two cases today. We'll bring this one in our next video, and we'll spend a couple days on him. Every quadratic function has a U-shaped curve or graph that is called a, do you remember the funny name? Okay, it is a parabola, spelled like parabola, pronounced parabola. So you might remember that when we talk about that leading coefficient a, this guy right here, so the 2, the invisible 1, the invisible negative 1. Remember when we talked about that being positive, something happened with the parabola. Do you remember what that is? The parabola will open up. It will hold water, okay? It'll look something like this picture. And oh, by the way, if we look back at our parabola dude, our quadratic emoji, these were all the parts of his face that would have a positive a, and notice all the parabolas are opening up. Well, in contrast, if that leading coefficient is negative, then the parabola will open down, it will spill water, look like this, and the only parabolas that were opening down on the quadratic dude were his eyebrows. So just to go back for a second to this page, positive 2, positive 1, these both would open up, negative 1, this guy would open down. Now there is a line that passes through this center point, which we're going to name in just a second. And you'll see that line is sort of like, if this was on paper, you could fold the parabola and this right-hand arm would fall directly on this left-hand arm. This is called an axis of symmetry. It creates the same amount of space to the right of it. So if I come over to this point on the parabola, and I was to go the same number of units in the other direction, I will hit the parabola again. So this axis of symmetry, you could fold the parabola on itself and it would land perfectly on itself. Same thing over here. Now the axis of symmetry is going to have something to do with this vertex point, but let's just remember that, look, it is a vertical line. And from Unit 4, a vertical line is always x equals a number. X equals a number. Y equals a number would be horizontal. And you remember in class I was always using my arms to kind of show you that. But a vertical line is x equals a number. Let's talk about that number, what number, in just a second. But this point right here, which is the highest point if the parabola opens down, and the lowest point if the parabola opens up, is called the vertex of the parabola. And it will be a coordinate pair. So it could be like 2, 3, or 0, 0, or 1, 4. And the vertex is the most important point. We always start with that. We know where that should be on the graph. So he is very important, as we're going to talk more about going forward. So let's just take a look at y equals x squared. And let's talk about how we would graph it. We're going to bring our buddies back. You might remember the Fab 5. There they are. We could substitute those in. So I would take -1 and square it. And remember, -1 times -1 is +1. And if you're doing this in a calculator, you've got to catch that input in the gloves, in the parentheses. Otherwise, the calculator is going to tell you it's -1. Make sure you use your parentheses when raising a negative number to an even power. Same thing here, -2 squared would be +4, 0 times 0, 1 times 1, 2 squared is 4. And we're going to see that symmetry as we plot those 5 points. -1, 1, -2, 4, 0, 0, 2, 4, and 1, 1 would be right here. And you can even see I went further to plot the 3, 9 and the -3, 9. You can see this parabola form. Notice that its A would be the invisible 1, so it is positive and it's opening up. Its vertex right here is that bottom point of that parabola opening up. That is called the vertex. It's 0, 0 in this particular case. And I want you to look at the red line that runs through the vertex, that vertical line right through the vertex, and I want to write the equation of that line. So it's going to be x equal, because it's a vertical line, and it will always be x equals the x coordinate of the vertex. So in this case, it will be x equals 0. Now you might remember back from Unit 3 and family functions that we called this parabola the quadratic parent function, and then we would talk about all other parabolas and how they differed from the parent function, and that's what we'll talk about going forward today. Just a little bit more vocabulary. When the parabola is opening down, that means it has a negative negative number in front of the x squared term. This is the highest point. The y coordinate, so this point right here is -5, 8. The output of 8, the y of 8, will be the highest point of this function, and that is called the maximum. You will never get a y greater than 8. That vertex is the maximum, and the y coordinate will tell you what that maximum is. So it is 8. That function never goes higher than a y of 8. If it opens up, that vertex point is no longer a maximum, because it's going to, the function is going to keep going up and up. You can see the arrows, but that is now the minimum. And again, the y coordinate, in this case, the vertex is 5, -6. That function will never have a value outputted that is smaller than -6. That -6 is the minimum value of the function. So the y coordinate in the vertex is either the maximum or minimum value of the function. So let's just take a look at another one. Here comes the Fab 5. I'm going to use those and put those in. I'm going to see what happens. We know we're expecting a U. We're expecting it to open up because this is a 1/2. If I start getting something that looks like it has a waist, where it comes in, or it looks like a W, something is wrong. We know what this should look like. You might want to take out a piece of graph paper if you have it, or just sketch on a piece of paper, do the math, and check this. So why don't you pause the video and see if you can do this one yourself. Okay, now that you're back, let's take a look at the table. Did you get the same values I did? And then if you put 0.5 here, of course, that's okay when we're graphing to be able to do that. So when I graph it, this is opening up, the vertex is going to be a minimum. There should be no point below it. So when I plot it, you'll see over here, there is the 1, 1/2. There's the 2, 2, the negative 1, 1, the 2, negative 2, 2, and I put my curve in there. Don't forget your arrows because it keeps going. We talked about in Unit 3, like domain and range. The domain, you can put any x values in, but the range, the smallest will be 0 because that's a minimum, and it would go up to infinity. You might even remember talking about interval notation. So it would be bracket 0, infinity, parenthesis, if you remember that discussion. But there is my quadratic graph, in this case a parabola, opening up, and you will notice that it got wider. It's fatter than the parent function. It's still vertexed at the same point. It's still opening up, but it's wider. So this 1/2 sort of made it grow slower. It's taking longer to go up. So having said that, we need to kind of experiment with the y equals ax squared and just kind of understand what is happening with that a. So again, what I would recommend is if you even just take a piece of paper, if you have graph paper, that would be great, pause and just see if you can put these graphs in and start to understand what's happening with the a. And I'll come back in a second. We'll put them up and see how you did. The other thing before you graph them is to kind of guess, kind of make a hypothesis about what you think is going to happen with the -1 or the 2 or the 4. What will happen to the graph? How will it transform the graph from the parent function? Okay, let's take a look and see how you did and if you understand what's going on here. So remember that the black one is the parent function. That's y equals x squared, and I've got my cursor moving on it right now. When we put the negative in front, it reflected, and still every one of these still has its vertex at 0, 0. Hasn't moved that way, but it has reflected with the negative or gotten wider or narrower with the number in front. So if you notice the 2 and the 4, the 2 made it go narrower than the parent function, the 4 even more narrow. So the higher the number absolute value-wise, so we're talking about a positive here. So the bigger that value, the narrower it gets, it grows faster. When we put the 1/2 in, notice it's wider than the parent function. It's kind of meandering up. It's taking longer to grow. So that fraction makes the function look wider. So now the question is, what happens when we put a c? So these are going to be y equals ax squared, plus c. We're going to leave the bx term out for today in that quadratic, standard form. Well, we know that all of these are going to open up, and we know that all of these are going to open down. We know that all of these are going to be wider than these, but what does the -5, the 1, the 4, and then the -2 do? So again, what I would recommend is just making a guess and doing a little graphing, making a conclusion, drawing a conclusion rather, and then trying it and then see if your conclusion was right. Don't just wait for me to present it. Try to do that thinking beforehand to see if you can come up with it on your own. Pause the video and I'll be back in a second. Okay, let's see how we did. So, you know what? Before we go on, why don't you, if you haven't had a chance, take a look at these and do the same thing, because I believe the next one, I don't know if I give all the answers at once. So pause the video, look at these, draw your conclusions. Okay, let's see how we did. Oh, I was wrong. So it's one set at a time. So notice that the parent function is the blue one. It's vertexed at 0, 0. It goes through 1, 1, 2, 4. This is the quadratic parent function. It's the blue one. Every one of these parabolas is the same width because the a didn't change. It basically just slid. It just translated that parabola either up or down. So notice that now the y-intercept isn't 0, it's 1. And on the red one, the y-intercept is -5. And you'll remember we did talk about that in Unit 3. Let's take a look at that other set. Remember, we said they were all going to open down. We said that we expected them to be wider. This isn't the parent function, but it is sort of the one that is vertexed at 0. It's negative, so they're all opening down. And notice that all three of these, because they have the same A, they're all opening down and they're all the same width. But notice that the green one is shifted down 2 units for its y-intercept, and the red one is shifted up 4. And again, I think you'll remember we kind of had that discussion back a few units. So here's kind of what we can conclude today before just doing some practice graphing. The sign of the A determines what? Think about it a second. It's really 2 things. It's going to determine whether the parabola opens up and down, but it's also going to determine what? It's going to determine how wide or how narrow the parabola is. Now, I want you to think in absolute value. I don't want you to think about negative. So just think about positive numbers. The bigger that A is in a positive way, the narrower and the smaller, less than 1, it will be wider. And then finally, today, what does the C do? That C is going to shift that parabola up and down. Its y-intercept will go up and down. And that's basically all we're going to talk about today. So aside from a couple of new vocab words, you should feel like we've done a lot of this before. So before we go on, here are 4 parabolas and 4 quadratic functions. Pause the video and just see if you can match which one goes with which without kind of making a table, without doing a table of values. Okay, let's see how you did. So notice that both of these parabolas open up, so we need to have a positive A, so that would have to be B and A and B. And remember that the bigger number will make it grow faster, so that's why this one would be B and this one would be A. And then we're going to come over here and we're going to flip them. So as we flip each one of these, they will have a negative, so it has to be these 2. And the one that is narrower will have that bigger absolute value. So the absolute value of -2 is 2, which is bigger than the 0.5. So that's going to stretch out faster. Also notice he has a +2 y-intercept, where down here this guy has the -2. So that's the way they should have matched. I hope this brought back a little bit of Unit 3 and function families and the quadratics, what happens with the A and what happens with the C. Anyway, so have a great day. And the next time I talk to you, we will put that BX term in.